Okay, so this is review for test number 9. Okay, so let's take a look at the first one. It says, name the quadrant or quadrants where each of the following trig functions fall. So for the first one, we have cosecant theta equals 0. Is greater than 0, sorry. So remember, cosecant is the reciprocal of sine. So we're thinking where a sine greater than 0 means sine positive. So remember, our quadrants, all students take calc. Sine is positive in quadrants 1 and quadrants 2. So that means cosecant is positive in quadrants 1 and quadrants 2. All right, so let's take a look at the next one. Let me just get rid of the check. All right, so the next one we have here, we have theta is less than 0 means sine is negative. Tan theta is greater than 0 means tan is positive. All right, so sine is less than 0 means sine is negative. Sine is negative in 3 and 4. Tangent is greater than 0 means tangent is positive in 1 and 3. So I'm looking for where sine is negative, tan is positive. That's quadrant 3. Okay, let's take a look at the next one. Okay, so the next one we have cosecant theta is greater than 0 means cosecant's positive, and cosine theta is less than 0 means cosine's negative. So remember, for cosecant, we're going to think sine greater than 0, sine positive. Sine is positive in 1 and 2. Cosine is less than 0 means cosine is negative, and cosine is negative in 2 and 3. So I'm looking where sine, which is cosecant, positive, cosine negative, that's quadrant 2. Okay, so let's take a look at number 2. Okay, so number 2, we want to convert the degrees to radian measure. So remember, to convert from degrees to radians, you're going to put with pi over 180. And you reduce. All right, so 220 degrees would be 220 pi divided by 180. And then you're going to, in your calculator, you're going to put 220 divided by 180, reduce it, and you get 11 pi over 9. Okay, next one, 585 degrees, put it with pi over 180. In your calculator, plug in 585 divided by 180, put it into a reduced fraction, so that's 13 pi over 4. Okay, so let's take a look at the next one, number 3. Now we're going to go the other way. We're going to change from radians to degrees. So now remember, pi radians is equal to 180 degrees. So we're going to change our pi to 180. So it's going to be negative 3 times 180 divided by 4. Type that into the calculator. So negative 3 times 180 divided by 4, and you get negative 135. Pi over 8, so that'd be 180 divided by 8. So type in your calculator 180 divided by 8. And you get 22.5 degrees. Okay, so let's take a look at number 4. Okay, so number 4, I have secant of x minus 4 and cosecant of 5x plus 10. Find x. So now notice it's secant equals cosecant. Those are cofunctions. So cofunctions when they're equal, the angles add to 180. Okay, now how do I know they're cofunction? Because this is secant and this is cosecant. It has co in front of the secant. So when they're equal to each other, the angles, these guys here, have to add up to be 180. So x minus 4 plus, I'm sorry, they add to 90, not 180. I'm sorry about that. They add to 90. They're complements. All right, so combined like terms, so we have x plus 5x is 6x. And negative 4 plus 10 is 6 equals 90. Minus 6 from both sides, so we get 6x equals 84. So now divide both sides by 6, so 84 divided by 6 is 14. So x is equal to 14. All right, let's take a look at number 5. So again, same thing here. We have tangent 4x equals cotangent of 5x. They're cofunctions. They're equal to each other. When cofunctions are equal, the angles add to 90 degrees. So we have 4x plus 5x equals 90. So this is 9x equals 90. So x is equal to 10. Okay, so let's take a look at number 6. It says find the complement in the supplement if it doesn't exist. Now notice that these are in radian measure, and how do I know? Because there's the pi. Okay, so remember, complement means two angles, two positive angles that add to 90. So to find the complement, you do 90 minus, it's 90 minus the angle. Okay, but we're in radians, so it's going to be pi over 2 minus your angle. Okay, so let's start with 2 pi over 11. So the complement would be pi over 2 minus 2 pi over 11. So remember, what you're going to plug in is 1/2, because I want pi in my answer, because that's radian measure. So you're going to type in 1/2, and you're going to minus 2/11. And make sure you get your fraction. So it's going to be 7 pi over 22. 7 pi over 22. All right, now let's do 23 pi over 36. So this is the complement. So it's pi over 2 minus 23 pi over 36. So type in 1/2 minus 23 over 36. And remember, you're going to have pi in your answer. So what we actually get a negative 5 pi over 36. So remember, complement and supplement has to be two positive angles that add to 90 or 180. So this is negative, so this would be D and E, does not exist, the complement. Okay, so now let's do the supplement. So remember, the supplement is when you have two angles that add to 180 degrees. So we do 180 minus the angle. Now 180 in radians would be pi, so it's pi minus the angle. All right, so let's start with A. So it's going to be pi minus 2 pi over 11. So remember, that's 1. So you're going to type in 1 minus 2 over 11. Okay, make sure you convert it back into a fraction or use the fraction key, and you get 9 pi over 11. Okay, and now let's do 23 pi over 36. So it's going to be pi minus 23 pi over 36. So in your calculator, you do 1 minus 23 over 36, and you get 13 pi over 36. So that works. Okay, so let's take a look at number 7. Number 7 says, find one positive and one negative coterminal angle to negative 415. So remember, coterminal, you add and subtract 360 to get what you want. All right, so I'm starting off with negative 415. I'm going to add 360. So type in your calculator, negative 415 plus 360. That's negative 55. So that's actually a negative coterminal angle, so that satisfies the negative part. Add another 360 because I need to get into the positive numbers. So negative 55 plus 360, and we get positive 305. So those are my positive and negative coterminal. All right, let's take a look at number 8. Number 8 says, write sine 295 as a function of a positive acute angle. So when we see positive acute angle, we're talking about reference angles. Reference angles. All right, so let's graph 295. 295 terminates in quadrant 4. So I want the reference angle. Remember, the reference angles form terminal side to x-axis. So this is your reference angle. So we do 360 minus 295. My reference angle is 65. Now remember, sine is negative in quadrant 4, so I have negative sine of 65. All right, let's take a look at number 9. All right, so number 9 says, let me just make it a little bit smaller. The point 35, comma, negative 4/5 is a point on the unit circle. Find sine theta, cosine theta, and tangent theta. All right, so now if this is a point on the unit circle, I'm just going to make this a little bit smaller. So if this is a point on my unit circle, and the point is positive x, negative y, that means it's a point on the unit circle in quadrant 4 because it's a negative x. Sorry, it's a positive x and a negative y. When you have a point on the unit circle, right, remember this is xy, but the point on the unit circle is cosine theta, comma, sine theta. So remember, cosine is your x, sine is your y. So cosine theta, which is your x, is equal to 3/5. Sine theta, which is your y value, would be negative 4/5. Now remember, tangent theta is the ratio sine theta over cosine theta. Now sine, we know, is negative 4/5. So it's negative 4/5 over, and cosine is 3/5. So we're going to do same change flip, so it's negative 4/5 times 5/3. We get negative 4/3. That's tangent theta. So remember, that's only true, though, when your point is on the unit circle. Okay, that you can make x is sine and y is, the x is cosine and the sine is the y value. All right, so number 10, it says, find the difference quotient. So here's the formula for the difference quotient, and I'm using f of x equals 2x squared minus 3x plus 5. All right, so let me just write this down here so I have room. So I have f of x okay, so we have f of x equals 2x squared minus 3x plus 5. And here's your difference quotient. F of x plus h minus f of x all over h. All right, so I'm going to start with this first. This is my input. I'm going to input that into all my x's. So it's 2 times x plus h squared minus 3 times x plus h plus 5. Now it's minus the whole function, so minus parentheses, 2x squared minus 3x plus 5 all over h. Okay, so I'm going to start with this, x plus h squared. So it's 2 times, so remember x plus h squared is x plus h times x plus h. So it's x squared plus 2xh plus h squared. Now I'm going to distribute the 2. So we get 2x squared plus 4xh plus 2h squared. That's this. Distribute the negative 3, so it's minus 3x minus 3h plus the 5. Now distribute the negative, so minus 2x squared plus 3x minus 5 all over h. Okay, so let's simplify this here. 2x squared minus 2x squared cancels. Negative 3x plus 3x cancels. And 5 minus 5 cancels. So I'm left with 4xh. And then I have plus 2h squared minus 3h over h. Now you're going to reduce. So h and h reduce here. H and h squared reduce to h. And h reduce here. So I get 4x plus 2h minus 3. That's your difference quotient. Okay, so let's take a look at number 11, which is factor. Okay, so we have here 3x to the third minus 81. So right away I notice that there is a GCF, and the GCF is 3. So then I also notice after I factor that out that I have perfect cubes. So remember, this is going to be your SOAP. So remember, SOAP, small parentheses, large parentheses. So it's same sign, opposite sign, always positive. So I'm going to use the minus since that's what I have here. So same sign, opposite sign, always positive. So it's going to be A, B, and then it's A squared, B squared at the ends of the big one, and in the middle is A times B. All right, so now you have to get your A and your B. Your A comes from the cube root of x cubed, which is x, so there's your A. Your B is the cube root of 27, which is 3. All right, so now I'm just going to plug everything in. So it's going to be x minus 3 times x squared plus 3x plus 3 squared. Make sure you change that to 9. So it's x minus 3 times x squared plus 3x plus 9. Okay, and let's look at the last problem, which is a no calculator problem. Okay, so it says no calculator, find the key features, and then we're going to graph this. So we're looking for the holes, vertical asymptote, horizontal asymptote, slant asymptote. Remember, you can't have vertical and horizontal at the same time. X, Y intercepts, and domain. All right, so let me write this down. Let me get nice, big, clear, white paper here to start this off. So my function is f of x equals x minus 2 over x squared minus 4. So I notice right away that I can factor the denominator. It is the difference of two perfect squares. So I have x minus 2 on the numerator. In the denominator, I have x minus 2, x plus 2. And then I notice, oh, I can reduce. These reduce. That means there's a hole at x equals 2. So remember, you find your 0. So now this is my cleaned up version, 1 over x plus 2. So let's rewrite that. This is your new function now. F of x equals 1 over x plus 2. All right, so now let's start with the hole here. So for your hole, right, I know my x is 2, so I just got that here. To find the y value, you plug in the 2 for x. So it's 1 over 2 plus 2. So it's 1/4. There's your y value. Your vertical asymptote, you're going to take your cleaned up version, set the denominator equal to 0, and get x. So x is equal to -2. That's your vertical asymptote. Okay, your horizontal asymptote, that's when you compare. So the denominator, right, has a degree of 1, and the numerator, there is no x, so it's a degree of 0. That means the denominator is growing faster than the numerator. So that means if my denominator is growing faster, the denominator is getting bigger. So that means my actual fraction is getting smaller, which means it's approaching 0. So it's y equals 0. Okay, your x-intercept, remember, is when y equals 0. So we get 0 equals 1 over x plus 2, cross multiply. We get 1 equals 0, so that means it does not exist. Your y-intercept is when x equals 0. So we get y equals 1 over 0 plus 2. Y equals 1/2. So it's 0, 1/2. Okay, so now we're ready to graph. Okay, so let's start with the whole. We have 2 Sorry, I'm just putting some tick marks on here. All right, so we have 2, 1/4. So it's 2 and then up a little bit for 1/4. And that's a whole, so I should not be making that a solid circle. So 2, 1/4, so open a circle. Our vertical asymptote is x equals 2, -2. Our horizontal asymptote is y equals 0. Okay, so my y-intercept is, which is right here, 0.5, so it's right here. Okay, so now remember, I have to make my table of values. So I'm going to put that right over here. Squeezing it in. And the function is 1 over x plus 2. All right, so I am definitely going to pick -1. I'm not going to pick 1 because obviously it's going to be a decimal in here. So I am going to pick -1. So let me use -1 in the table. And then I do need a couple numbers on the other side of the asymptote, so -3 and -4, and that's plenty. -3, -4. All right, so let's plug in our numbers. I'm going to use, I guess, the purple. So I have 1 over -1 plus 2. So that's 1 over 1, which is 1. So -1, 1. So that means your graph is going to look like this on the side. Come down. Remember, jump over the hole and put your arrow. All right, now let's plug in -3. So I have 1 over -3 plus 2. That's -1, so this is -1. So -3 is -1. And we'll plug in 4, so it's 1 over -4 plus 2, which is -2. It's -0.5. So it's negative, so it's like this. So it's going to come down like this. Remember, don't hit the asymptotes, don't touch the asymptotes, don't cross the asymptotes. Okay, so that's it. Happy studying, and I'll see you guys tomorrow. Have a good night.